Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. To your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So in this video, let's finalize our review on factoring. If you want to anticipate the solutions to these problems, you may do so by pausing the video. And that should be the good step for you to enhance your skills in algebra, especially on factoring. Because this is already reviewed, therefore you are expected that as viewers, you are able to answer these problems. There are 17 problems in this video. So for the first part, this is by trial and error. Factors of 21 are uh, 3 and 7, since this is 4, positive 4. So 3, 7, the difference is 4. So 7 should be positive and 3 should be negative. So z plus 7 and z minus 3. That should be the factors by trial and error. This one, the factors of 6x squared are 2x and 3x, 6x and x. Then 15, 3 and 5. Since this is x, so let's have 3x and 2x. So if the partner of 2x should be 5, and the factor of the partner of 3x should be 2x and 3x. So 5, then 2x, 3x plus 5, and 2x minus 3 to make it x, so that 2x times 5 is 10x, and negative 3 times x is negative 9x, so that makes it x. So the factors are quantity 3x plus 5 and 2x minus 3. So we rewrite this as 2 plus 5x minus 12x squared, and again we factor this by trial and error. So of course 2 are 2 and 1, and negative 12x are 2 and 6, 3 and 4. So let's have the middle term is 5x, positive 5x. So I have here 2x, then x, 2 minus x, then x, 5x, so 3, 3, 4. So it should be 2, 1 plus 3x, and 6, 8x, negative 6. So 1 plus 4x and 2 minus 3x. So those are the factors: 2 minus 3x and 1 plus 4x. So we check 2, 8x minus 3x is 5x, then negative 3x, 4x is negative 12x squared. The next one, the first term is a perfect square. The last term is also a perfect square. The square roots 2h and 7w. 2h times 7w is 14hw times 2, so 28hw. Therefore, this is a perfect square trinomial. Since this is negative, the factor should be 2h minus 7w quantity square. So that's it. So square of the first, then twice the product, 2 times 2h times negative 7w is negative 28hw. Square of negative 7w is 49w squared. So that's the factored form. 5 is common to each term. So let's factor out 5 first. 5 quantity z squared minus 6wz plus 9w squared. Z square is a perfect square. 9w square is also a perfect square. Square root z, 3w. So z times 3w is 3wz times 2, 6wz. So again, this is a perfect square trinomial. It is 5 times z minus 3w quantity square. By checking, we notice that for the first two terms here, b is common. And for the last two terms, 3d is common. So factor out b, b times quantity a plus 2c, then plus 3d times a plus 2c. Since a plus 2c is common, let's factor it out. So complete factored form, a plus 2c, quantity a plus 2c times quantity b plus 3d. Next, here, the 2 is 2a for the first two terms. 2a squared is common. For the last two terms, 2 is common. So let's factor out 2a squared. So we have 2a squared quantity a plus 2 and minus, factor out 2 first. So 2 times quantity a cubed plus 2a squared minus a minus 2. And here, for the first two terms, a squared is common. So we have 2 quantity a squared times 1 times a plus 2, then minus quantity a plus 2. So that's why we have minus a minus 2. A plus 2 is common, so this is 2 quantity a plus 2 times a squared minus 1. 2 quantity a plus 2 times quantity a squared minus 1. This is difference of two squares. Factors are a plus 1, a minus 1. So the complete factored form therefore is 2 times a plus 2, a plus 1, a minus 1. So we write this next problem as quantity m plus w square, perfect square. 4 is a perfect square. And for the middle two terms, let's factor out 4. So quantity m plus w square plus 4 times quantity m plus w plus 4. So notice that this is just one quantity m plus w, one quantity. So if you imagine this as a square plus 4a plus 4, which is a perfect square trinomial, because square root of m plus w square is m plus w, square root of 4 is 2, so 2 times m plus w times 2, so that's the middle term. So that's why this is a perfect square trinomial. The complete factored form is m plus w plus 2 quantity square, m plus w plus 2 quantity square. Perfect square, and these terms are terms of a perfect square trinomial, so we write this as x squared minus quantity a squared plus 6ab plus 9b squared. So again, this is a perfect square trinomial, a plus 3b quantity square, this one. So this is x squared minus quantity a plus 3b quantity square. So we have difference of two squares. Factors are x plus quantity a plus 3b. The other factor is x minus quantity a plus 3b. So x plus quantity a plus 3b, x minus quantity a plus 3b. So the final answer, x plus a plus 3b times quantity x minus a minus 3b. The first three terms are perfect square. The first three terms are terms of a perfect square trinomial. The last term minus 9a square is a perfect square, 3a quantity square. So this is x plus 2 quantity square minus 3a quantity square. So we have difference of two squares. Factors are x plus 2 plus 3a. Then the other factor x plus 2 minus 3a. X plus 2 plus 3a, then x plus 2 minus 3a. The first term is a perfect square. Last term, perfect square. So we cannot factor this by trial and error, but if the middle term happens to be 6x square y square, then this should be perfect square trinomial. So it is lacking by 1x square y square. If we add and make this 6x square y square, then we should also subtract x square y square, which is a perfect square trinomial. So we transform this into x to the fourth plus 6x square y square plus 9y to the fourth, then minus x square y square. So the first three terms now are terms of a perfect square trinomial. Then this is a perfect square also. We can write this as quantity x square plus 3y square quantity square minus xy quantity square. So we have difference of two squares. So factors are quantity x square plus 3y square plus xy and quantity x square plus 3y square minus xy. Next, this one is supposedly a perfect square trinomial if the middle term here is 20u square v square. So it lacks 4u square v square, and 4u square v square is a perfect square also. So therefore we transform this into 4u to the fourth plus 20u square v square plus 25v to the fourth, then minus 4u square v square, which is a perfect square trinomial. The first three terms are terms of a perfect square trinomial, which is factored into 2u square plus 5v square quantity square, then this is minus 2uv quantity square. So 2u square plus 5v square quantity square minus quantity 2uv quantity square. So we have difference of two squares. Factors are quantity 2u square plus 5v square plus 2uv and quantity 2u square plus 5v square minus 2uv. Next, this is perfect square, and however it is not a perfect square trinomial, but if the middle term happens to be 20, then 20a square b square, then it is a perfect square trinomial. So it lacks 9a square b square, but 9a square b square is a perfect square. Therefore, we can transform this into 4a to the fourth plus 20a square b square plus 25b to the fourth b square, 25b to the fourth rather than minus 9a square b square, which is the same as that original. The first three terms again are terms of a perfect square trinomial, written as 2a square plus 5b square quantity square, then minus 3ab quantity square. So we have difference of two squares again. Factors are quantity 2a square plus 5b square plus 3ab, and the other factor 2a square plus 5b square minus 3ab. Here, perfect square, not a perfect square because this is 21. But if this happens to be 25, then that would become terms of a perfect square trinomial. So it lacks 4d to the fourth, and 4d to the fourth is a perfect square. So we can write this or transform this into 9c to the fourth minus 30c squared d squared plus 25d to the fourth, then minus 4d to the fourth. We can also factor this by trial and error if you want, but let's just write this in this manner. This is now a perfect square trinomial because square root of 9c to the fourth is 3c squared, square root of 25d to the fourth is 5d squared, and twice their product is 30c squared d squared. However, this is negative, so meaning to say this is 3c squared minus 5d squared quantity squared, then minus 2d squared quantity squared. So we have difference of two squares. Factors are quantity 3c squared minus 5d squared plus 2d squared, and 3c squared minus 5d squared minus 2d squared. Since we can combine like terms, so we have 3c squared minus 3d squared and 3c squared minus 7d squared. In fact, if we factor this original expression by trial and error, these are supposedly the complete factored forms. So 9c to the fourth, negative 21c squared d squared, negative 9c squared d squared, that makes it negative 30c squared d squared. Negative 3d squared times negative 7d squared is positive 21d to the fourth. So that checks supposedly, but we can factor c3 here. 3 times quantity c squared minus d squared and 3c squared minus 7d squared. So we have difference of two squares here. We can factor this further into c plus d, c minus d. So the final factored form is 3 times c plus d, c minus d, and quantity 3c squared minus 7d squared. The next batch of problems, because the degree is, these are polynomials and the degree is higher than 2, so we factor this by synthetic division. So remember the synthetic division, we collect coefficients in descending order of the variable, then we attempt a root and make sure that the sum of the constant in the last would be 0 to consider that root is the root of that expression. So we have 1, negative 2, negative 5, 6, negative 5, positive 6 rather. The possible roots, because this is 1, would only be roots of factors of 6. Factors of 6 are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So let's try root which is equal to 1. Then we draw horizontal line. We have leave a space here. Bring down this first coefficient, which is 1. Then multiply 1 times 1. Remember the synthetic division. 1 times 1 is 1. Put it here. Then add. That's negative 1. Then 1 times negative 1 is negative 1. Add negative 6. 1 times negative 6 is negative 6. Since 6 plus negative 6 is 0, that means this is the root. And if we write this in factored form, this is x minus 1, x minus the root. And the meaning of these terms here, these are the coefficients of the quotient, because the degree is 3, then we have found one root, then this is reduced to 2 second degree. So the meaning of this is x squared minus x minus 6. And this time we can factor this by trial and error because the factors of 6 are plus minus positive 2 and negative 3. negative 3, positive 2, 6, 1, negative 6, 1, like that. So let's choose x plus 2 and x minus 3, because negative 3x plus 2x is negative x. So the factors are x plus 2 and x minus 3. So if you check, that's x squared minus 3x plus 2x, so negative x. Then 2 times negative 3 is negative 6. So that's the complete factored form by trial and error. Then the answer, complete factored of this, is x minus 1, x plus 2, x minus 3. So x minus 1, x plus 2 times x minus 3. For 16 and 17, let's have them on the next slides. So for 16, we collect coefficients 2, 5, negative 14, and negative 8. Because this is 2, the possible roots would be factors of 8 divided by factors of 2. So one factor of 8 is 4, and one factor of 2 is 2. So 4 divided by 2 is 2. So I'll try 2. So by the way, this is factored by trial and error also, although we have synthetic division. So again, the explanation, the possible roots would be factors of negative 8 divided by factors of 2, because this is 2. If this is 1, then the possible roots will only be factors of 8. So factors of 8 would be plus minus 1, plus minus 2, plus minus 4, plus minus 8. So because we factor this by trial and error, there is a case where we have 4 as factor of 8 divided by 2 as factor of 2. So that's why we have 2. So we draw horizontal line again, bring down 2. 2 times 2 is 4, and 5 plus 4 is 9. 2 times 9 is 18. Negative 14 plus 18 is 4. 2 times 4 is positive 8. Negative 8 plus 8 is 0. So that means 2 is a root, and the factored form is x minus 2. The meaning of this term, from third degree it becomes second degree, so this is 2x squared plus 9x plus 4, which can be factored by trial and error as 2x plus 4, 2x plus 1, and x plus 4. So 2x plus 1 and x plus 4. So check 2x squared, 8x plus x, so 9x. 1 times 4 is 4. So the complete factored form of this expression is x minus 2 to x plus 1, x plus 4. And finally, number 17, we have 3, 8, negative 21, negative 18, and 8. Then possible roots would be factors of 8 divided by factors of 3. Since factors of 8 are plus minus 1, plus minus 2, plus minus 4, plus minus 8, factors of 3 are plus minus 1, plus minus 3. So we have the possibility, so after trials, we have 1 and factor of 3, 3. So therefore, I'll try 1/3 as root, but this is just one of the possibilities. I attempted other roots then until I came out with this 1/3 here. So bring down 3, draw horizontal line. 1/3 times 3 is 1. 8 plus 1 is 9. 1/3 times 9 is 3. Negative 21 plus 3 is negative 18. 1/3 of negative 18 is negative 6. Negative 18 plus negative 6, negative 24. Negative 24 times 1/3 is negative 8, and this is 0. So one factor is x minus 1/3, in factored form. And the meaning of this, because it is originally 4th degree, this is now 3rd degree. 3x cubed plus 9x squared minus 18x minus 24. And in each of these coefficients, 3 is common, so we factor out 3. So we have 3 quantity x cubed plus 3x squared minus 6x minus 8. Therefore, 3x to the 4th plus 8x cubed minus 21x squared minus 18x plus 8 is equal to 3 times quantity x cubed plus 3x squared minus 6x minus 8 times this factor, which is x minus 1/3. Then we can write this into 3x minus 1 all over 3. So 3x to the 4th plus 8x cubed minus 21x squared minus 18x plus 8 equals 3 times quantity x cubed plus 3x squared minus 6x minus 8 times quantity 3x minus 1 all over 3. So wherein we can cancel 3. So that reduces to quantity x cubed plus 3x squared minus 6x minus 8 times 3x minus 1. So this original expression in this factored form. But we can still factor this. There's a possibility. We factor this by synthetic division. Collect coefficients 1, 3, negative 6, negative 8. And the possible factors this time would be factors of 8. Plus minus 1, plus minus 2, plus minus 4, plus minus 8. So with all trials, let's try 2. So bring down 1, because 2 is a factor of 8. 2 times 1 is 2. 3 plus 2, 5. 2 times 5, 10. Negative 6 plus 10, 4. 2 times 4, 8. Then negative 8 plus 8, 0. So take note that I already tried different possible roots, and I got this after 2 or second trial. And do not say that you can right away get the root. The possible root should be roots or factors of 8. So that's why I just presented the root where we have 0 here in the last part. But I'm not saying that I got this root after just one trial. So it may be 2 or 3 trials. So the meaning of this is x squared plus 5x plus 4, because this is 3rd degree. So after finding this root, the factored form is x minus 2. Then we have x squared plus 5x plus 4, which can be factored by trial and error into x plus 1, x plus 4. So finally, the complete factored form of this is 3x minus 1, then x minus 2 times x plus 1, x plus 4. 3x minus 1 times x minus 2 times x plus 1 times x plus 4. So that's it for this video. I hope that you were able to follow the explanations, understand the solution, but it needs trial and error and experience also, especially for the technique in completing the square first before we come up with difference of two squares.